what is the next generation algorithms, right? Okay, there was deep learning that was mostly supervised. If you had lots of labeled data, you could get impressive performance. But what about so many other issues, right? If you only had limited supervision or self-supervision, how do you make these things work? What are the algorithms? How do you generalize to new domains and tasks, right? Quickly adapt with few short generalization. The ability to have robustness to all kinds of changes and corruptions.
Hello everyone, Ken here, back with another incredible guest for this week's video. Today I had the awesome opportunity to speak with Anima Anandkumar. She's truly someone who's shaping the future of machine learning and AI. Anima is currently the Director of Machine Learning and AI Research at NVIDIA. As you'll learn about in the video, her team is working on the cutting-edge algorithms that'll be optimized for NVIDIA's latest GPU architectures. NVIDIA just broke 16 records in the most recent machine learning performance benchmark, so it looks like they must be doing something right over on that end. She also is actively involved at CalTech as a Bren Professor and the co-director of the Decision Optimization and Learning Department at the school. If we went through all of Anima's full list of accolades, we probably wouldn't have time for our full conversation, but she was recently recognized by VentureBeat for her pursuit of excellence in AI research. Aside from her incredible resume, Anima was extremely personable, and she was able to make the complex research topics that she's working on sound simple and intuitive to me. In this interview, you'll get to hear Anima's story, learn about the difference between ML research and other areas of data science careers, and also get some insider knowledge about what the future of AI could look like in the next few years. At the end of the video, I'll also announce the winner of the Jetson Nano that I was awarding in my PC build video. A link to that PC build video is linked above and below in the description. Now on to the interview. Why don't we just jump into some of the kind of broader interview questions. Hopefully it'll flow very much like a conversation, but kind of guide it starting with some of your background into your kind of career, and then finally rolling into what the future of machine learning AI looks like, because of anyone I've talked to, I think you probably have a better understanding of that. Definitely way more than I do. So
I try.
Perfect. So I'd love to understand, when you first developed your interest in machine learning and some of the techniques that you're using, was there kind of an aha moment, or was it all of your studies leading up to that point just kind of you found yourself working in this stuff and you're like, oh, okay, this is what I do now?
Well, I think the first time was all the way back in high school, right? Like, I always loved math and science as a kid, even very early on. But the first time I discovered probability, that's when I was like, and really like almost amazed that you can reason about uncertainty and just randomness, right? Like, because, until that point, it was very much about determinism, right? Like, oh, you have laws of gravity, you can precisely say what it is. And then suddenly you're like, no, maybe not. There is the quantum phenomenon, there is now probability, and that's what helps you deal with uncertainty. And I think that's when I realized there is so much of, right, operations you can do. You can, have a strong foundation with probability. And maybe that's the first time I thought about, connecting that to learning, and all the way through my undergraduate school. And then in grad school, I started working on statistical signal processing. So it wasn't AI right at the outset, but on the other hand, I was asking how we could reason about measurements on a wide range of different sensors, like now what we call Internet of Things. Back then it was called sensor network. And to now take all these imprecise measurements and to come up with something that's actionable and precise, right? That is the processing of knowledge and information. And that was the starting point, but then that led me all the way towards thinking about, like, more generally, how do we learn large scale distributions of data? This is uncertain, there's a lot of noise. How do we handle this in high dimensional settings, what we call high dimensional statistics? And that's what led me to probabilistic models and what's known as graphical models, how graphs can give us relationships between different sets of variables. And then through that into deep learning, also being able to learn features from data itself. So yeah, it's been an exciting journey, kind of seeing all the way from, first understanding probability to using that to reason about the uncertainty in so many domains.
That's awesome. One thing I really like to highlight in everyone's story that I talk to is that it's clearly a transition. You learn a little bit more, and you continue to develop and find one out about yourself and your interests, but also more about this whole broad field that, you talk about AI, you talk about machine learning. It's not something that you just jump in and say, I want to learn machine learning. You're solving individual problems along the way. And then you look back and you say, wow, I've got a good body of knowledge about this field, about some of the elements there. So I think so many people are trying to jump into data science, they're trying to jump into AI, and I don't think that that's always the best approach. The best approach is you kind of get your foot wet, and then you get into knee level and then chest level, and then you look back and you're like, wow, I'm all the way here. I'm almost drowning because I have so much data. So along this journey, what do you believe some of the characteristics that you have or that you've accumulated were that helped you be successful in this field?
Yeah, I think you bring up a very good point, right? Because, if you're dealing with as complex as problem of AI, which is probably the biggest challenge humanity ever has faced, right? Where do you even start? And I think that's where you have to break down this complex problem into well-structured, smaller problems, right? And to get a handle on that, I think getting some foundational knowledge is so critical, right? Like, as I said, I started first learning probability, right? I started with linear algebra in my undergraduate classes, right? All that build up is important because then you can kind of build stronger structures on top of that. And at the same time, also getting knowledge just from doing hands-on work, right? Which is the engineering approach. Okay, let me try training a model, right? To recognize cats versus dogs, something, right? At a fairly toy level, but you're doing this hands-on, you're building the neural network, you're training this. And especially if you can't make it work and you have to tweak it, you also get some intuitive knowledge. I think that mix of both will be powerful because you're now understanding, right, at least some of the core mathematics behind it, but also you have that working knowledge. And that's what I would say can be critical for success today in the modern day era of AI and deep learning.
Do you have any preferred approach to doing that? So something I enjoy doing is if I'm trying to work with, let's say, a new algorithm that I haven't had experience with before, what I'll try to do is I'll implement it in Python, I'll get it to run, I'll try and fool around with some of the parameters, and then I'll go back and try and learn the math from, not starting from zero because I know like what goes into it and what comes out of it and some of the constraints, but I at least have some framework to put the math on. There's like a skeleton for me to look at. Is that a common approach, or do you generally recommend saying, hey, maybe I learn a little bit about the model first and then I try and implement it and then I go back? Is there a structure that you prefer or that you think is maybe superior?
I mean, certainly not one size fits all, right? Because all of us think differently. In fact, some of us visualize. I just learned some people cannot visualize, right? Their brains are not visual. So, I think as now with the personalization of education, hopefully people can on their own figure out what works best for them. Personally, for me, I'm very mathematically oriented, right? So I like to maybe chart out some toy examples of that. Like if I had a toy version of this, what would this algorithm do? Or, when will this succeed? When will this fail? So I like to more reason intuitively and then go to some implementations, right? So I'd like to first kind of build that up without implementing, but that's how maybe I've been trained and I've been trained to think. But for you, if it works the other way, that's great, right? There is definitely not one path towards innovation and research.
Well, I really like that you highlighted that, because that's something that I get asked very frequently is, where do I start? What courses should I take? All of these things. And the biggest thing is that you have to experiment and figure out what works well for you. You have to learn your approach. If I really like one instructor, that could be the difference maker, that I just resonate well with how they teach. It might not even be the coursework or how it's taught. And so I love that you were able to kind of unify that concept, because that's something I think a lot of people really struggle with. So,
and I think that's also because, just to add to that, right, is because you have to be very patient if you're learning such a complex topic, right? And for so many people, it's like they like to see results. They like to, which is good. I mean, right, if to see some results, but also I think this back and forth, right, if they're failing to move out of that, just zoom out and think more bigger picture, right? Like why, maybe what is the skill they're lacking or knowledge they're lacking, because they're just stuck. I think that's when, this more non-traditional way of learning becomes challenging, when people get stuck, right? Because then, they don't know what to go and look for, what to study in terms of foundations. I think that's why you need a little bit of logical reasoning for sure, right? If like, okay, now if this is working, now B is working, right? You kind of go step by step, you carefully check, you do the ablation studies. So there has to be a scientific method when it also comes to implementations and experimentation, right? If you're methodical, then you can localize where is the problem, and maybe that's when you can go back to looking at those concepts and understanding that deeply if there is a gap.
Awesome. Well, I think the big takeaway there, right, is that everyone has their own way of doing it, but you have to make it into a process, no matter if it's you start at the end and work back, or you start at the beginning and work forward. Know how you do it and make it repeatable. So yes. One thing that is, I wouldn't say unique about your background, but one thing that I have no exposure to is the academic path, getting a PhD. I'd love to hear about your transition from academics into your positions in non-academic positions.
Yeah, I mean, now's the great time to be in both these worlds, right? Yeah. I never imagined, I think I would have the chance to do both and find ways to bridge the gap between industry and academia. Because when I got my PhD about a decade ago in 2009, that was the height of the financial recession. So, it was quite a challenge, but at the same time, I think back then there was no AI in industry. There were no industry labs. And I wanted to work on AI, right? So it was very clear academia was the place to do that. But then once the deep learning revolution started, everything changed, right? There's so much activity in industry, so many resources, and also the requirement of data and infrastructure that's much more in industry compared to academia. So I wanted to also make the transition while retaining a foot in academia, and that's what I did first at Amazon and now at NVIDIA. The ability to ask, okay, what are the now problems that require scale and engineering, but also the fundamentals and foundations, right? And how to bring all of that together. And that's what makes it exciting.
One thing I find interesting with academia in general, and I'd love your thoughts on this, is that I find at the very top, the research is the most cutting edge. You're trying to solve the problems that have not been answered yet. But as you trickle down to, let's say, like an intro class, you find that some of the things are not up to speed of what's going on in the real world, like industry-wise. For example, I had a course where we were learning, data, like a basic data analytics course, and they were teaching it using SPSS, which I think is, I've never seen someone use SPSS outside of a math and research perspective. Where do you think that kind of, that stretching that divide kind of comes from, is that we're doing the most cutting edge research, but at the same time, some of the things we're teaching our students is actually lagging behind what's going on in practice?
I think because, universities have tended to be more conservative, right? And change is slow. Except research is driven by, right,
the individual,
faculty and individuals and groups. And so I think we also need more innovation in teaching, and we need more teaching professors who can make that their core focus. CalTech, in our computing and mathematical sciences area, we have many teaching professors who are excellent, who do an amazing job, who also, develop new techniques, to use the latest programming languages or frameworks. I think we need to make that also into a profession that we value, and universities need to wake up to that, I think, more.
Well, I think they're going to be forced to with what's going on in the world right now in terms of technology innovation and things like that. So hopefully we'll see that, and I really expect we will. I'm pretty optimistic about all of the online learning opportunities that are coming about. So I'd love to kind of move on to learn more about your research that you're doing at NVIDIA right now. I think that, again, you're at a company that is on the cutting edge of the field, and you're leading the AI research there. So I think it's you're in a very unique position to, one, have a lot of influence on what happens next, but also to be able to tell a story about what we're working on now.
Thank you, Ken. I mean, it's been so exciting to be part of NVIDIA, the journey that I've seen NVIDIA go from graphics processing to the center of the universe for computing. And now with AI, right? It's just been incredible. It's always been inspiring. And now to be part of that, I feel very privileged. And here at NVIDIA, we have so much of support to do, right? Open research, like ask now, what is the next generation algorithms, right? Okay, there was deep learning that was mostly supervised. If you had lots of labeled data, you could get impressive performance. But what about so many other issues, right? If you only had limited supervision or self-supervision, how do you make these things work? What are the algorithms? How do you generalize to new domains and tasks, right? Quickly adapt with few short generalization, the ability to have robustness to all kinds of changes and corruptions. So those are the core algorithmic research we do. And then the question of how it gets applied to so many different domains, right? So the cutting edge is now not just images, but videos, but also higher dimensional computer vision, right? If you're thinking of autonomous driving, having multimodal sensors and LiDAR and vision all together. So how do we deal with such immense number of dimensions and scale? And what are the neural network architectures and algorithms that make that possible? So back when I started my faculty career, almost a decade ago, time flies, my core area of research was tensors back then, and even now I'm continuing that in my group at NVIDIA. And there the idea is how you can use these higher dimensional generalization of matrices to incorporate multi-dimensional data, as well as neural networks now not just being matrix multipliers, but having more complex high-dimensional operations. And so that's one core area where, it's kind of been an interesting journey all the way from my early faculty career to now at NVIDIA, building like the primitives at low level and taking that all the way to applications like autonomous driving and robotics and video analytics. So, and that's why it's a very broad brush, right? Thinking of those foundational algorithms. But at NVIDIA, we have so many teams looking at now these cutting edge applications and then interfacing together to make this possible.
And how does that, I guess, intersect with the technology that you guys are building? Are you building a lot of these architectures very focused on what's the next generation of actual hardware technology there's going to be? Or is it the other way around, where the hardware is following the infrastructure or the architectures that you're building?
It's always a combination, right? And we'll see more of the co-design and the co-evolution in the next decade, because in a way, the example I gave you in terms of, right, we had designed the tensor algorithms before, but now we realize, we can have these primitives that are really efficient, and we have experts in architecture and CUDA who can enable us. And so we can get end-to-end speed up and compression, very large models now being compressed and still getting the same performance. So that's one example of where, right, we are kind of building new primitives into hardware to enable the algorithms. And the other way is also true, right? So now we have mixed precision training, and we have new ways to quantize and make our networks more efficient. The question is, can we train better, right? Can we do better quantization methods? And that's the algorithm design, to take advantage of tensor cores, to take advantage of mixed precision. So, and at NVIDIA, we see, right, that back and forth, and that's very exciting.
That's awesome. I mean, it's very different than any of the work I've ever done. My work is almost always an application of these things. So with that in mind, I'm very interested in how the role of a machine learning researcher differs from that of a data scientist or machine learning engineer that's kind of focused on, on the application of these things. And what are the different skills that you might need to be successful in one that you might not need to have in the other one?
Yeah, I think both are very important roles in any company, right? And it really depends on the context, right? Because it depends on the company somebody is at, what are the needs there, and what is the expectation of the role. But if it were to be NVIDIA, here in my group, for instance, right, when it's machine learning researcher, we are going back to more of the foundations, right? Like, what are the new optimization methods? How do I design a new meta learning algorithm, for instance, right? But we are also closely paying attention to applications, right? But we have like engineers and scientists in the application domain, for instance, if we are working on video analytics, we have the core experts there who are engineering that, making that work, or whether it's autonomous driving and we want to apply active learning, we know somebody who, right, or a group of people who understand that very well and are architecting that and are getting to state-of-the-art performance. And so the boundaries are very blurred because they're also scientists in many ways, right? And also in my group, we have researchers with core domain expertise in robotics, in computer vision, in tensors, right? So there is, the boundaries are more fluid, but usually the separation is in terms of, is your day-to-day job more in terms of engineering and making things scale, making things work, and you're mostly taking off-the-shelf algorithms, or you're kind of, right, having somebody else develop the algorithms and using them. I think that's what I would distinguish the two, whether you're a builder or a user of algorithms.
Very cool. And you kind of touched on my next question, but I figure I'll ask it anyway. I think some expansion could be really, really cool. For your team specifically, what do you look for in a new researcher? You can talk about the tangible skills, but also some of the not intangibles, but the not purely quantitative. Exactly. Yeah. You know what I'm saying.
Absolutely. I think, it has to be well-rounded, right? And it's not, again, one size fits all when I look to hire researchers, because it's looking at, first of all, their individual research record, right? What have they done in the past, but also how are they presenting that? How did they go about deciding why they picked this problem? Why did they go down this path and not something else? I think that's, to me, is critical, and there are many who are not always able to explain that, right? Like, just, I think picking something just because it's trendy is definitely not a good answer to that. And so what is this kind of unique aspect, right? Like, I think you were asking me earlier, why did you get into the field? And being able to kind of also methodically explain how they went about doing their research, I think that's an essential one. And then lastly, with respect to like people skills, certainly the communication, right? Like how they're able to kind of connect with everyone and able to explain to not just researchers, but also others. I think that's critical. And also the openness, right? Like to think about ideas or being even challenged, if somebody says there's a better way to do this than what they've done. I think that openness is so critical when it comes to research, because research is a lifelong learning job, right? Absolutely. So, and you have to be open-minded.
Awesome. And so one thing you said is that you look at their history of research. Does that come from their academic career? Does that come from contribution to open source communities? Does that come from their own projects? What does that generally look like in a candidate for you?
I mean, it can be a combination of all this, right? Because, my group so far has researchers who are PhDs, but, in many of the adjacent groups, there are certainly those without PhDs, right? So it's not a requirement that's set in stone, but then, having open publications makes it easy to assess that, right? If that's not there, then you really have to go by right? How they're able to explain, how they're able to make a case for themselves that, they were able to achieve something in a much more proprietary setting that they cannot maybe give all the details or publish about it.
Awesome. Well, I feel like I'm beating this one to death a little bit, but just one last question kind of regarding this. What advice would you have for someone who's interested in getting into machine learning research or AI research?
Yeah, so it depends on, again, which stage they are. If they are in their undergraduate studies, making sure, right, the core math classes, that they take that seriously and just build that good foundation, right? Linear algebra is so critical, right? Probability and statistics. I think that foundation is a starting point. And then online, there are so many great courses, right? There is, of course, the NVIDIA DLI, the Deep Learning Institute, that has so many variety of courses for much more hands-on, right, aspect of all the way from like preparing the data to end application, every aspect of it. We go through that. There's also open source resources like fast.ai, which has excellent material. So I think this combination of some of the core foundations and also the working knowledge and much more, like online courses that give them that ability.
Very cool. Well, I will say something. You had mentioned that you shouldn't choose research decisions because they're trendy. I went into data science and YouTube because they were the two trendiest things. So, no, I'm kidding.
Well, you're doing a great job with that and helping the world learn more about AI, which is great.
I'm kidding.
That shouldn't be the only reason. Let me revise that. Right?
I'm kidding.
So they need to have something more.
Oh man. Yeah. I think that I didn't plan it that way. Let's put it that way. I think I was into data science before it was cool, or I'd hope to think so. You were in it way before it was cool, so.
I'm sure you had your reasons. You kind of have to just think about that.
Of course. So I wanted to move on more into the actual impact of machine learning and AI, and talking about the kind of communities there. First, I'd like to ask you, perhaps in the last 10 years, what do you think the greatest advancement in machine learning and AI is? And then maybe in the next 10 years, going into the future, what you think that advancement could potentially be? Obviously, we have no clue of the future, but you probably have a slightly better look into it than most people.
Yeah, over the past decade, it's been such an exciting decade for AI, right? And most people will say the biggest advance is deep learning. I would just kind of make it much broader than that, because deep learning was one piece of it, but to me, it's the trinity coming together, the trinity of data, deep learning algorithms, and the compute infrastructure, especially the GPUs, all synergizing and opening up this entire universe. Right, because the developments were all happening separately in each of those three facets, right? We had the internet just growing and collecting all this data, right, in the web. We had neural networks all the way back to 30s, right, if not earlier, but it was, right, conceptual. No one could make them work earlier. And we had the GPUs, but they were being used for graphics processing and HPC, right? And so realizing that these three could come together to create magic, I would say that's been the most exciting advance over the last decade.
Awesome. Very cool.
Yeah, and for the coming decade, yeah. Sorry, is that what you wanted to?
Yeah, that's what I was going to ask you. For the next decade, I'd love to know what you think. Is it a continuation of that, or could it be something else that perhaps I am not privy to?
I think for the next decade, certainly we'll see this maturing more, right? Because, the GPUs, what is the next generation hardware? How do we, right, have tightly designed co-design of both algorithms and hardware together? That's going to be exciting. Data as well, in terms of not just going by label data, but all kinds of noisy data and related data. How do we use that to learn efficiently, especially being able to do unsupervised learning at scale, right? And creating self-supervision, meaning we create our own supervision due to various transformations of data, how to enable that and learn good representations. I think that's going to be critical. Being able to learn at scale with limited supervision and being able to generalize across various domains. So I call this generalizable AI. So it's not just designed for one narrow task. It's easily applicable to a wide range of different tasks, even domains. And you can create now AI for a new domain with just what we call few shot examples, right? Only a few number of examples we're able to generalize. I think that's where we'll see a lot of exciting developments.
Is that pretty much all transfer learning, or are there different, I guess, architectures that can enable that even further?
So the transfer learning, the way it's commonly used today is typically that there's a pre-trained network, right? And then you bring in new data and try to fine tune it, or only take the top layers, right? Even you kind of freeze everything below and train some few layers on top, right? But the thing is, you can do much more than that, right? Because if you're now aware that you're learning on a variety of different tasks, maybe you can do multitask or meta learning. If you're doing domain adaptation from one domain to another, right? You also have this data in the new domain, but it doesn't have labels. How do you use it while training your source domain? You know, instead of just pre-training being agnostic to everything else, can you use it while you're doing the training, right? And if you have only limited number of labels, can you do active learning and query new ones in an intelligent way? So that's why it's now a much bigger universe of possibilities than the transfer learning we've currently been using.
Very cool. That's something I would really like to learn more about at some point in time. That's not something I don't do too much deep learning in my work. It's something I'm trying to learn more and more about. So all of this is fairly novel and very fascinating to me.
It is cutting edge, right? And ultimately what we want to aim for is like, you know, self-training and self-learning, right? Like if the AI realizes that it doesn't have enough information, it goes queries for new information, right? So it kind of continues to learn what we call lifelong learning or never-ending learning, right?
That's scary,
and
but very cool.
realizes on its own, right? So that's the holy grail.
Very cool. And so, you know, a lot of this conversation has been focused on a lot of data, a lot of different applications. Something that I think is very fascinating is the kind of micro-powered AI, or like localized AI or network AI, where you're doing, you know, very advanced calculations, whatever it might be, on small devices. Do you have any examples of how that's being used to really make a difference now, or how it could be used in the future to really make a true global impact?
Absolutely. You know, edge AI is also the revolution for the next decade, right? Like, and NVIDIA with Jetson and Xavier and all the platform, right? Enabling that, whether it's in the cars, drones, right? Whether in various industrial sensors, all these variety of applications, which now AI is not just centralized in the cloud, but also can be in small to medium devices of various kinds. And you see so many examples of that. I think, you know, the NVIDIA partnership with Mercedes-Benz is very exciting, right? Now the car is going to be a supercomputer, you know, the next decade, right? And of course, going all the way to level 5 autonomy is the ultimate goal, but everything else around it too, right? Like being able to understand all the sensors of the cars, being able to have good interaction with the passengers and drivers, you know, conversational AI, right? The right interfaces, all that's part of that computing platform, right? So that's where now edge AI will really have its moment in the coming decade, in the ability to quickly build so many different kinds of devices and in many domains.
That is so cool. And I would like to take a second to plug that I'm giving away with the partnership, in partnership with NVIDIA, one of the Jetson Nano devices for anyone to actually experiment with this. So I'll link the video related to that above and below. I just want to make sure that everyone knows that you know, I'd love to be able to help share some of that technology with everyone.
Absolutely. And I saw that on Twitter, and that's great. And, the Jetson Nano is so cool, right? Like what used to be like Raspberry Pi and prototyping, now you can put that on steroids. You can kind of have your own image detector or video detector and build AI, but also kind of do many creative things with it.
Yeah, well, one thing that I am really focused on this channel is how to improve your job chances. And the best way, frankly, is through projects or through actually building stuff. And one of the most unique ways to do that is, using some form of robotics or integrating AI with something tangible. And the Jetson Nano really does give you that ability.
Absolutely. And I just want to add to that, there's research now for all aspects of that, right? Of course, we want to have edge AI hardware that's efficient, that can, kind of work on limited battery power, limited bandwidth requirements. But also in terms of robotics, you mentioned like the Isaac platform, right? Like being able to do high fidelity physical simulations and augment that to the real data, right? Because in robotics, collecting real data is super expensive. You can't have like a robotic arm or a leg do like a million moves, right? I mean, we could collect from the web for other things, but not for this. And that's why I think simulations will be critical to enabling a lot of these robotics applications.
Awesome. So I wanted for the last couple of questions just to shift gears a little bit and think more about the broader community or the broader, not problems per se that are facing ML, but just some, kind of be wary of type things. One thing I'm very interested in is what you believe the single biggest ethical issue is related to machine learning and AI research.
Yeah, I mean, over the last few years, it's been great to see AI move into the real world, right? But at the same time, many things just, move too quickly sometimes without proper testing in place, proper regulation in place. I think, and that's true with every technology, right? I wouldn't single out AI, but the space is also so much faster than ever before. So the potential for adverse effects is also high. Right? So I think we've seen now more awareness around AI bias and the potential ill effects for AI that's not trained properly, that's trained on biased data that has not tested well. I think that's what we'd like to raise more awareness and ultimately have the right form of regulation that doesn't thwart innovation, but at the same time, right, protects humanity from the ill effects. I mean, one example that's been very visible is face recognition, right? And it was first shown by Black researchers, Joy Buolamwini and Deb Raji in the gender shade study coming out of MIT, that many of the publicly available APIs for face recognition, whether it's Amazon or IBM or all these companies that were providing this, had such poor performance on Black population, especially Black men. And so I think having diverse set of researchers and workforce in AI is also important, because then they bring a different perspective and realize there are problems with the AI we are launching. And since then, and now with the Black Lives Movement and all the awareness around, these companies finally said, we'll stop selling that to law enforcement, which I think is the right, because what matters is not just that the AI is biased. I mean, that's a problem, certainly, but also the societal context in which it's applied. Law enforcement is a life and death situation for especially Black people. And it's important to keep in mind that this system has to be very accurate if we are putting this out in the field. In fact, there was a report in Detroit, an African-American man being mistakenly identified by face recognition and leading to his arrest. And we know in such situations, there have been lots of deaths earlier. So that's why I think it's very pertinent that there is regulation in place for sensitive applications like this, law enforcement, crime recidivism, loan approval. All these are aspects that affect human lives adversely if there's a wrong decision. So that's when we have to be super careful.
Well, that actually is a really good segue into kind of my last question is, obviously the world doesn't seem exactly inclusive right now, or at least the United States doesn't feel as inclusive as it perhaps has in the past, or hopefully it will be in the future. And what are some ways that we can maybe foster more of a community around machine learning and AI, making sure that it is inclusive and that actually everyone can have a voice or everyone can participate?
It's interesting you bring up by saying maybe it's not as inclusive now as it was in the past. I'm not sure. I think there is much more awareness, right? Like, I think that's one of the positive powers of social media, that more people are speaking up and there is diverse voices heard. Of course, the ones that get amplified are usually not that, but at least there is now the possibility of making those communities come together, right? Like, for instance, I joined Twitter just a few years ago, and the reason I joined was there were so few women on Twitter talking about AI, and especially talking about possibly the dangerous effects of AI, right? There's always kind of this bias towards just saying, let's hype up AI, let's promise the world it'll change everything, right? And the journalists have been very guilty in just kind of taking that without any critical questioning. But I think it's been more of the diverse, right, communities within AI going on social media and talking about it more that has been the game changer. And with all of the issues in the community, right, whether it's harassment or toxicity that people are talking about, it may seem like it's not inclusive. I mean, not just in AI, broadly in the world today, within the US. But I think that's better than having it all swept under the rug like it was before, right? Like, now we're talking about it, only then real change can happen, whether it's the Me Too movement or the Black Lives movement. There are deep systemic issues with sexism and racism today, and we have to address this, right? And we have to bring this out into the open. So that's how I see everything being played out, and that's what gives me hope that this is part of the churning process and we can do much better. And that's what I've seen in the AI community. I think the lowest point was in 2017 NeurIPS, back when it was called NIPS, and there was all these tech bro parties and people joking about NIPS. I mean, it was just really terrible environment in terms of how women felt, how minorities felt, and then Black in AI got created, Latinx in AI got created. All these communities decided to bring together researchers from these affinity groups and also make them feel like they're part of the bigger community. The name change movement, brought about the issues of how people, push back even for fairly benign changes, right? But then it opened up the eyes to so many who hadn't seen the sexism and other issues, right? Because they suddenly realized that if people are being so toxic, like giving me gun threats because I asked for a name change, there is deep issues in the community.
Major issues, yeah.
Indeed, right? So, and yeah, it was a difficult time. It was a scary time in many ways, but it's also given me hope because I've seen so many allies help me, build this community, and we continue to do that. That's what gives me hope.
Awesome. Well, that to me is so exciting that now a lot more things are out in the open. We can talk intelligently about all of these things, and I think that there used to be, and I think in tech there still are some dissenting voices that are getting overshadowed now, which is nice by popular opinion, by inclusion, which is really nice to see, especially on some of where that's not happening in some, I guess, less tech forward parts of the world. So my last thing is I'd love to be able to share anything that you're working on, any either social goals, anything related to your work, anything related to communities that you'd like to share. You have an open floor to talk about anything you'd like.
Yeah, I think I'd allow for more people to participate in AI, right? Democratization of AI is such an important goal. So don't feel intimidated. Don't feel like, that this is only for a select few. And especially if you don't look like a stereotypical researcher, right? There are role models now from diverse communities in AI, and we want more of that. So we'd love for you to be part of that. Some nonprofits I can think of. One is AI for All, for underrepresented communities in high school, right? High school students being able to do research in AI. I think that's a great opportunity to apply for if you're a high school student. Fast.ai has been great in terms of, right, giving the resources for learning AI at your own pace. And yeah, I think those are all great endeavors for us to be including more people in AI and in AI research.
Awesome. Well, I'll be linking those below in the description and in the pinned comment. I'll also link to your Twitter down there. So if you get quite a few more Twitter followers, I either apologize or so.
Well, most of them are great, right? And
Perfect.
now I've kind of figured out, like, there is the mute button and I can use it. So.
Excellent. Well, thank you so much again for sitting down, chatting with me. I think this will be so useful to everyone that's interested, one, in AI research, and two, just interested in understanding kind of the landscape of the field and where it's going.
Thanks a lot, Ken. It was a great pleasure.
So as you know, in my PC build video, I worked with NVIDIA to give away one of their Jetson Nanos. I really wanted to give back even more, so I arranged for them to give a little bit of free swag to a couple of the other names I really liked. So for the 2 honorable mentions, you will also get some NVIDIA swag in the mail. I've reached out to both of you. Please, contact me with your details so I can send some of that stuff out. So the first runner-up is Fenrir. That also goes off some of the Norse mythology that I went with in my first build. Fenrir is a great white wolf who I believe is the son of Loki and perhaps some other giant or god. And I think that goes really well with the theme of the PC, which was kind of a beast. Also, the Norse mythology carries on. So I really like that name. The next one is Hytalik, which is also a mythological serpent. I thought that there was a nice corollary between Python, serpent, electric serpent. That was a cool name. I probably would have went with that one for first place, except I had a nightmare trying to pronounce it. Hytalik, Heineken. So the winner of the Jetson Nano is actually Poe. I thought that this was a great name from Kung Fu Panda. The panda stuff is obvious with the black and white theme, but pandas is also one of the main data science libraries that we use. So there was a lot of really good parallels there. This is also something that was pretty easy for me to remember. So for the prizes, Gaurav wins the Jetson Nano for his name Poe. Kurt wins some NVIDIA swag for the name Fenrir. And then the username Anhiva wins also some swag for the name Hytalik. So again, thank you everyone for submitting your names. I'd still love to hear more. I thought this was a really fun exercise, and maybe I'll try and get some branding on the computer in the next couple of videos to celebrate its new name. As usual, thank you so much for watching. Thank you, Anima, for your awesome conversation, and good luck on your data science journey.